there's three kind of approaches to these that are common. These kind of, especially things like MVC, but in general, these approaches, they are often built into frameworks. How do you do this? So you see it a lot in web frameworks as well, for those of you that do web things. It's like, how do you do this linking up is a serious question. So one of the approaches is something called model view controller. So it contains three components: the model, the view, and the controller. This is the oldest one. It comes partially out of Smalltalk. It's very common in web development. You really separate out the action and the reaction. So basically, how do you handle the synchronization here? Well, controls do not update their state by themselves, or in this case, views. So you update something, you then need to say, okay, we put that into a controller, and the controller goes to a model, and that updates something, and then that informs the view that something changed. So you have to go basically around and around with this. One caveat is if you see frameworks that say they use MVC, they often don't. And in particular, when you see the challenge here is if you have a really small scale, small granularity events like mouse presses, or a user moved pressed the key, those kind of things, should they be handled locally in the view, or should they be going through all the model, including business logic? Let alone if you then got input methods or something like that, where you've got temporary states, like there is a character in process of being created. That becomes a bit of a mess. So the model basically there is just business logic and data. So it kind of wraps both. So it's so there might be a database behind there, for example, but it wraps kind of all the important things about the data. So it's the boss of the data, and it's fairly clear. It doesn't know about the UI. It just has the ability to send out events. So those callbacks that we have been talking about. And that's also in the sample code for your assignment. There is this, okay, I changed something. Okay, then go and have a look what changed. You can give more specific information, but again, it's not really necessary. But the model is ignorant of the UI we have, and use events for manipulation. That's normally just function calls, method calls. They call events partially because of, say, Smalltalk. Smalltalk models objects as being independent things that send messages to each other. That's kind of the idea. But of course, the message is just a function call. And the model updates the view of updates. So the view just displays stuff, it doesn't do anything. And so what you often see is kind of a control and a view object. So it might have the view actually as a control that it is linked to do some of this gluing stuff together. So basically you have, but what you end up is one view per UI element performed. So you can also have, within this architecture, you could have kind of one model that drives multiple views that display the same things, maybe in different ways. Certainly you've seen this in applications where that happens, where you see the same data in two different places and it updates synchronously. The controller basically does the translation between user actions to what does this mean for my data, for my model. They press this button here. Okay, you wanted to add an address, or you want to this text box represents a name, things like that. So how do you do this? So this invokes model operations. Again, it's a one-to-one relationship between the controls, or the thing that the user sees. One of the challenges with this approach is it involves a lot of often actually really dumb components that don't really have a lot of code in them. That is, okay, I need a model. The model, what does it do? It just shovels the data to the next thing. It does the obvious things, but you have a lot of those things around. If you don't have interesting behavior, you still need to create those things. So you get basically a lot of indirection that can, in and of itself, become rather hard to see. So it also kind of puts kind of some requirements on what your UI elements can do, especially that they can actually handle controls and stuff like that. So handle events and be monitored. And in this case, so the view is a rather passive thing. It just sends out events possibly, and it displays stuff. Doesn't really have any behavior. So yes, it can quickly become boilerplate. So boilerplate is, oh, you have to put this code in just to make it work. It's not interesting. It's just lots and lots of, boring, tedious stuff. Like getters and setters in Java that Kotlin gets away with. Unless you have you can write the getters, you can make special getters in Kotlin, but only need to if they do something more than just shoveling a value.